Oi, there you go. Oops, that's huge. All right. Boom. Can you see my screen, Hank?
Let me have a look. Uh-huh.
All right. Shit. Hold on. Fuck. Come on. I gotta figure out how to do this. All right. So what I think you're thinking is that light bounces off the oil rig, which is on the right, and goes horizontally and bends down into the water. And therefore we don't see it. Is that kind of what you're getting at?
No, I'm saying we do see it. We do see the bottom of the oil rig,
Okay.
the pillars.
Yep.
You need
Cool.
to draw it on a globe and then
Okay.
have it 1 foot above the surface and then show
Yep.
how the light's bending down but not going into the water somehow. That's what you got to do.
I could probably show you that on the flat Earth here. It's the same idea. Same concept. Oops. Ah, fuck. Fuck this.
I just want to know how you know the path of the light to claim that it's going around a curve.
Right, because light bends down in a density gradient.
Oh, and
Okay,
you're
the sky's
assuming
blue
it's on the boat.
sometimes, but what does that have to do with you knowing the path of light?
When you say the path, do you mean the exact path of light?
Well, that's what you're claiming. You're claiming to know that the light goes around the curve of the Earth when the curve of the Earth is
Yes.
the thing in question. So the only way that you could know that is if you knew the path of light.
I know that light bends down, and necessarily that means we can see further than we could, or see more of it than we would otherwise geometrically.
That's what you would have to say if you were a glober and you're seeing something you're not supposed to
Right,
be able to see.
right.
But how do you know it? I get that you're saying it. It's like your affirmation. You wake up in the morning
Right.
and before you drink water or brush your teeth, you say light bends down in a gradient.
But then you agree with me. So do you agree with me or not?
No, I don't agree
Does
with
light
you
bend
to
down?
know the path of light, bro. I'm just saying
Right.
that at 1 foot observation height, you can see pillars that are sticking out of the water from 10 miles away. If the light was bending down off of the bottom of that pillar, there's only one thing below. That's water.
Oh,
If it's
okay. So
bending down, it would hit the water.
you are saying what I think you're saying, right? You are saying what I think you're saying, right? You're saying this. Cool. Right. This light goes out horizontally from the legs or wherever, it doesn't matter, and hits the water. Cool. That's what you're saying. There is another path from that same point that is also bending down. Fuck, I hate
So it's going up through the medium, and then what causes it to like bend back down if the light's going up? Because
the
light
gradient
wants to stay in the direction it's going in.
Right. This is the confusion you're having, right? If even though light is traveling up, the direction of the bend is down.
How do you know that's the path
Because
of
light bends in a
it?
fucking density gradient.
So it's going up and then it just horseshoes back down.
Right, because we're in a gradient and that bends the light down. So
Even
do
though
you
the light's
agree that it does that
up.
or not? Yes, it
How
might
could
be
I
traveling
possibly
up.
claim to know the path of light?
Oh,
I don't know
Jesus
how you
Christ.
could
I
either.
don't know whether you agree with me or not that light bends down in a density gradient. Can you answer that plainly?
I don't think it bends down like a curve. It changes incident angles, right? It changes angles.
Well, kind of. If you want to treat it as discrete layers, you could say that, yeah.
Just as if something is going away from you, you're going to get the same effect as if you're going towards it. So the whole bottom-up obstruction thing is just ridiculous to me. Of course you're going to have distortion. It's at the lowest part of the atmosphere. And to claim that it's 2 miles that are missing and that just means that it's not flat, like...
Hang on, we've got to sort this out first, Jared. So this light coming off the oil rig is traveling up, all right, but is curving downwards. Can you see the distinction that I'm making there?
Yeah, you're saying the light is taking like a left turn, like NASCAR.
Okay.
How do you know
However
that?
you want to do it. Because light bends in a density gradient. Do you accept that or not?
So you're saying it bends in a density gradient, which I'm not going to disagree with, because I don't like
Okay.
getting stuck on level 1 of conversations. So
No, neither
if it
do I.
bends in a density gradient at 1 foot and it's bending down, you're saying it's going up, then bending back down.
Yes.
So it's bending more than 8 inches per mile squared.
In the black swan, probably not, but close to it. It doesn't really matter.
So it's going
Somewhere
up,
around
then
there.
coming back down, but it's not bending
misunderstanding.
more than the surface of the Earth?
It's not
Yeah,
bending up and then bending down. If you look up and you follow, like you throw a rock, the rock, if you throw it, let's say towards the sun, directly towards the sun, it will then curve down and land on the ground. And that's this whole trajectory backwards is basically the light. Or let's say you are a person who throws the rock and there is another person who gets that rock into his face. The rock hits the person in the face from 30 degrees up the sky. That is the direction where the light is coming from. So he sees the rock coming from the sky into his face, but actually you have thrown it from the ground in a parabolic trajectory. And that's basically the same how the light goes. So the light goes.
I think what he's doubting, though, Snooze, I think the thing he's doubting is that the light traveling up, right, and then curves so much that it starts to travel down. I think that's what he's doubting.
But that's what I mean with a rock throwing, right? You throw the rock in the sky, and then it bends down. The trajectory of the rock bends down, but the person who receives the rock sees the rock coming from the sky. And that's the same with his light bending. So you see the rock higher in the sky compared to the position where it was lifted off.
Yeah.
So light behaves like the trajectory of a rock.
Sure. Do you have an issue with the path of the green ray? Do you have an issue with that?
Yeah. How do you prove it? How do you demonstrate it?
Light bends in a density gradient. Please just be very clear whether you accept that or not.
Why do I have to be clear? That's weird, bro.
Because you keep agreeing to it and then questioning it. Like, which one is it?
Okay.
Well,
so
I think we get it though. Like, can you go on to the next thing? Because, like, I think
that's
he
it.
answered it.
This is what they're claiming: the light's bending down around the curvature of the Earth. But first it goes up, and then it goes down. So
do you have an issue with it going up first? Do you have an issue with it going up first?
If it's going up, you're going to make it like change angles because in order for it to hit glass, right? If I'm looking at the plane of the glass, right, and there's a fish on the other side, and I'm perpendicular to that plane, it's a pretty clear image of the fish, right?
Yep.
But if I start going off to the angle and start looking left a little bit, then it gets all distorted.
Yep.
Right.
Light bends towards the more dense medium, right?
What angle is that light traveling through when it goes up? It should be bending the other way, shouldn't it?
Dictated by Snell's law. We agree. Right? But do you agree that light hits this oil rig and goes off in every direction? Right?
Yeah.
Light's bouncing off it everywhere.
Yep.
So do you have an issue with this green path, even though it starts off
because there's no fish tank there to bend the light down. And the vertical, it's vertical. It's not horizontal.
Does light bend does the atmosphere bend light?
It can. I think it's more like
fucking stop saying that you don't believe things that you then instantly agree to again.
That doesn't mean that you win the argument just because light has like a turbulent path through atmosphere. That doesn't mean you automatically
bends down
win.
Through a density gradient. Bends towards the more dense medium.
So everything you say about light is automatically true then?
Okay,
I'm asking whether you agree to it so we can either move on or I can demonstrate it.
What's the density gradient?
Okay, so the laser in a fish tank is a good example, right? You have someone shining a laser, right, at an upward angle into the fish tank. Right, and guess what happens to the light?
It goes through glass. Where's the glass in the atmosphere? I forgot.
Sure. Yeah, glass is not going to change the curve of the light once it's inside the fish tank. Yes. We can model that with
I heard
Snoozer as
Jesse
well.
say that he has to shine it through the glass in a certain way to make it do that curve.
No,
So
he just
I
has
don't
to
know.
point it upwards. The glass doesn't affect it. It just changes it for a split second, and then it comes out at the same angle.
So is a fish tank equivalent to the atmosphere?
No, the fish tank's not fucking relevant. That's what I just
why
said.
Use it? Why use it?
Because it demonstrates the curve.
But it's not
through a
relevant.
density. We're not concerned with the glass, right? We're concerned with the sugar water.
Then don't use it.
I'm concerned with the sugar water because it demonstrates the principle of the light curving through a density gradient. Right? You point the laser upwards. Point the laser upwards, and guess what happens?
Maybe we need a laser inside.
Look inside, you see the actual bending happens.
Going up.
Why can't you just shine it straight through instead of making it go up?
Right, because your doubt involves light that is traveling up, right, and then starts to bend down. That seems to be your doubt. But if we do it in the fish tank and we point it up, it starts curving and then curves down, so that it is now angling down at the end of the fish tank.
You can't
Does
feed
it
sugar
lift
to
the
fish.
object up?
Yes.
Sugar will kill fish.
Trivially true.
Roohif.
Fuck, it's 10 o'clock. I gotta go.
All right.
Yeah, it's such a trivially obvious thing, Hank. If light bends down, you will see more around the curve.
Has light always been down?
In a typical density gradient, yes. Very close to the surface, you can have inverted gradients, which is why I always say get away from the surface.
So showing that light bends down, though, doesn't prove how it would lift an object 330 feet up in the air to make it look like it's straight in front of you.
What do you mean straight in front of you? I don't know what that means.
The observation, the mountain is straight in front of me. Like I could see it. It's right there in front of me.
Okay.
So you want me to believe in refraction that's really lifting that image 330 feet up in the air, so I make that observation? But it's not a flat Earth observation because I'm missing 2 miles at the bottom. Like,
Well, a mile and a half, yeah.
I don't know, dude. Like, I don't know how you don't see like the problem with that.
Look, the amount of refraction in Canigou is typical. Like it's predicted by our atmosphere.
Well, yeah, it's only predicted because you're already putting it on a ball that's 3959 and all.
No,
Yeah.
Incorrect. No, incorrect. The gradient is vertical. Has nothing to do with the shape of the Earth.
Dude, what's happening is, and I've been here for a minute, so I know there's a flat Earth observation. Everybody's like, oh, what are they going to say now? And what you basically do is you just take the observation and then you just bend it to your globe, like doing
Incorrect.
whatever you want with
Incorrect.
light.
What did I just say? Literally, what did I just say?
Fluid. It could change.
What did I just say about the gradient?
Just because you show a laser bending in light,
I said it's vertical and has nothing to do with the shape of the Earth. The gradient has nothing to do with the shape of the Earth.
Listen, the fish bend downwards in the aquarium.
You're proving, that light bends down, but that doesn't just logically leap to, oh, I'm going to lift an object that's.
Yes, it does.
300
It's fucking trivially true.
Well, gradient has everything to do with the shape because you're claiming that it's making a shape.
No, the gradient has nothing to do with the shape. Right? We have to incorporate the gradient when we test the globe, but the gradient itself is completely
doesn't even exist. But it's dependent upon your model.
Okay. Yep.
Yeah, the observation
bring up the sensor.
Don't you have to go? Isn't it 10 o'clock? Yeah. All right. See you later, dude.
Bring up the sensor in your phone and measure the pressure at the floor, and then move the phone up to the ceiling. You'll see it decreases. I'll say it for the 5,000th time. The gradient is independent of the shape of the Earth. We must incorporate the gradient in our globe Earth predictions.
Now brush your teeth.
Anyway.
Amen.
Yep.
And then after you say it, after you brush your teeth, say it again.
We have to incorporate it into our daily lives. What do you think about the?
Pay your tithe to the gradient.
What it comes down to is that the light wants to swim downwards.
Real truth is he ran from Snax.
He couldn't handle it.
I know. As soon as he heard your voice, he was like, "Oh shoot, 10 o'clock, gotta go."
Yeah, he bolted.
I fucked him up, but I'll fuck up Embo too. Let's go. I ain't done yet.
Weak ass Embo.
What is your problem?
You and your globe.
Y'all trying to poison fish for one.
Y'all making the frogs gay for number 2.
Yeah, you talk about some gender gradient with the frogs. That's not
Gender
gradient.
gradient. They have created a gender gradient. Holy shit! Never thought about it like that. That's awesome.
Don't forget, they identify as astronauts. We went to the moon.
The Earth may look like a globe, but according to you, it identifies as flat. So we have to treat it as flat. But every single observation we make proves that it's a globe.
See, that's so
Then
funny
why do
though,
you invoke
because
direction card?
the observation comes and then nobody says anything until somebody does some fancy math. It's like, well, yeah, we're seeing it, so yeah, we're on a globe. Like it's just pre-assumed that we're on a globe, and we're obviously seeing it, so we have to explain it. And that's what it seems like to me. Because why can't the observation just be the observation? Why does I have to have all this light bends down and
Because there's this thing like called physics, and the fact that physics dictates that reality will behave in a specific way, and with that knowledge we can model what kind of shape the Earth would have to be to explain this observation. It's not that we assume light is bending down because we first assume there's a globe,
well,
and
it's not
then
as
we
if
need
you guys assume
light.
radius of 3959, right?
I'm cracking knuckles right now. It's all right.
That's a separate thing. That's measured by a completely different way. But my point is that light bending down is not an assumption because we assume the Earth is a globe and now we have to explain it. It's based on physics. Even if the Earth was flat, it would still be bending down. And here Flat Earth has a problem, because if it's bending down, then you would see the Earth look concave if it was flat. It wouldn't look like as curved. It would look as concave.
I appreciate your your thing. I mean, I get it when you say that. Like you said that earlier, I think, and I know what you mean by that. But I think where the disconnect is that we're experiencing reality just like you guys are, and so
all right, good cop. Now it's time for me. All right.
Okay.
The problem is that you guys are miscategorizing it, and you think that because you can say density gradient, and that's 2 words you can put together, that's actually defining what's going on, but that's actually not the case. What you've created is a waveguide, and light will follow a waveguide, and what you're the stupidity of all of that is making you think that it's on a gravitational contour that all this stuff's going on, when it's really that light has to follow the rules of fitting through stuff. This is why the sugar water thing works. And then you're miscategorizing it. Do you understand? Do you get that much?
Light has to follow the rules of how electromagnetic waves behave, which is dictated by Maxwell's equations.
This is about optics. Don't make it broadly categorize it. You know.
Optics is a result of that, because light is a wave.
Are you doing sugar water with ultrasonics or sound? No,
with light. With light, and light is a wave. So because in more dense air, the speed of light is slower than in less dense air. If you have light that is traveling through the atmosphere, you have this gradient, the upper part will be traveling faster than the lower part, and that will be causing it to bend down. That's the explanation.
The light is caught in a it's guided because of the internal reflection. It's guiding it in that path. That's why the laser bends in the tank, not because of gravity. Like a density gradient, if you want to call it that, forms, but like you're really just creating like a birefractive medium, right? It's got 2 refractive indexes in it, And a little cloudy gradient in the middle, yeah, I guess.
The change in the refractive index between any two layers that are like next to each other in a fish tank or in the atmosphere is way too small to have total internal reflection anyway. For it, you basically have to have two different media with drastically different refractive indices. But in the atmosphere, it's gradual. Like if you take 2 points that are very close to each other, they will have very similar refractive index because it changes very slightly over height.
Yeah, your point's very slight.
Your brain is very slight if you want to discuss in this way.
I don't know. I don't have my headphones on, but that sounded like an insult. I'll go into this further.
He's gonna take the gloves off.
Put my hearing aids in.
No, but do you understand though, from our point of view? Like, do you understand? Like, what I'm saying is that I believe that the observation is what it is, which is it's straight in front of me, right? And now I got to deal with somebody telling me that I'm actually not seeing that the thing I'm looking at is actually 330 feet over a curve, right? That's like hijacking my senses and telling me, well, you can't figure it out, so let me take control and you're going to believe this. Like, do you see where I find that to be a problem with this whole thing?
If you want to trust your senses with completely disregarding how optics and physics work, then you will notice that the sun is going below the water, or that ships are going below the water. That's what you would get if you trusted your senses.
Okay, I'll say it again because maybe you guys didn't understand it. If the observer is 1 foot above the water and the bottom of Hill House or Habitat is 1 foot above the water and the light is bending down like you guys say, what would happen? Would it disappear from the bottom up? Because the cranes has a little room for it to bend down. You know, hundreds of feet of room for the light to bend down. So some days you would only see the cranes. And then some days you'd see the whole thing, right? Is that right? If the Earth's flat and the light was bending down, it would hit the water and never your eye at the same intensity.
No,
right?
because the light scatters in all directions.
Light
scatters in all directions. So some of the light that starts off at going upwards at a 1 degree angle will hit your eyes. Some of the light will hit your feet. Some of the light will go over your head. That's why when you lay on the ground, you see it. When you stand up, you see it. But that will not cause the bottom to drop out first, like you think.
No, what? I'm trying to compare a flashlight to a laser beam here. It seems like.
Yeah, no, I'm comparing light scattering in all directions.
Flashlight and laser beam are not different. The only thing is that a laser is coherent.
Yeah.
So all light waves emitted by a laser are in kind of a same rhythm.
Well,
it's same light.
Same rhythm. Who's high here?
Yeah.
Honestly, guy, like it's that it's collimated. It's concentrated. There's like there's very little waste. I understand that light spills everywhere, but like the laser beam itself is concentrated. All the joules of energy are going to that fucking point, not splaying around.
You can do the same thing. You can put flashlight. You can put a light from a flashlight or from a normal light source.
Like
you can put light. Can you just hear me out instead of interrupting?
A flashlight is not going to bend over water like that, though.
Can you hear me out without interrupting? I also let you talk.
I have a problem doing this generally.
You can, yeah. And I want to explain it. You're strawmanning me, and I want to explain it. So you can put lenses in front of every light source, and you can also concentrate other light than laser light to be nearly parallel and nearly concentrated as laser light. And you can also, on light shows, you typically have spread out laser lights. For example, you have like a horizontal layer of laser light, you have a ring or a cone. You can even just put a laser light through a normal, like your normal glasses or so that you put on your nose.
We're having a conversation now about this?
And you will have a cone of light.
You're not going to overtalk me.
The property of laser light is not that it is parallel. The property that defines laser light is it is coherent, which means it has all the light in the laser light has the same frequency in the same rhythm. There is no phase shift.
Oh my gosh. What a fucking over nonsense about like that shit. Jeez. I mean, I'd duck out of this convo if you're going to be part of it.
Dude, all you have to say was,
that's a response, honestly? Like, man.
Okay, then explain me, what is the difference between laser light and a light from a light bulb?
It's like we're trying to do laps around here and you're putting up fucking roadblocks of like a minute of fucking trying to explain like like you don't have to explain the difference of a laser. And like I already understand it. Like you don't have to explain it.
Explain it to me then. If I'm so wrong, can you explain me the difference between light bulb light or a blue LED light and a blue laser light?
Well, I want to stick to this because it seems to be more pertinent. Is like an actual.
It's energy density.
Observation that's happened. Like, have you seen the observations of laser light that's been across flat water that's different distances, all observable, just like a flat Earth prediction would predict?
I have seen laser tests and also light tests. So you say a 5 kilowatt lamp has less density than a 100 milliwatt laser. The laser has higher density or what?
What does that have to do with an observation of laser light over water?
It's at the moment it's about the difference between laser light and normal light. So and it seems that some flat earthers are claiming that laser light is some kind of special light that can bend, but normal light doesn't. And
no, nobody's claiming that.
I have an understanding of laser light that is, it seems, wrong in your opinion. And now it's got the claim that the difference between laser light and normal light is a light density or energy density.
No, the difference is
so how it's made. Like, I mean, typically, like if you're talking about the pictures that we have of light bending or laser light bending over a body of water, right? Those are all like pretty much like consumer level. I don't know. They're running like 7 volts probably, or 9 volts maybe at the most. I mean, they're not like, you know, industrial military grade lasers, right? They have like a certain kind of build, right? It's different than a pen laser, right? Because those we know that they pretty much don't exhibit that, you know, because it's just not. It's how close you are to the body of water. Like the laser will want to drift towards the water because of electromagnetism. That was told to me by an engineer Glober person. Basically, there's no way that you can like if you put a laser close enough to the surface of water, it will hit the water because it will just be electrostatically drawn towards it. You can call that gravity, whatever the fuck you want, but there are some physics here that exhibits because of how that is acting. That I don't know if like you know, if we took a bunch of spotlights and condensed them down into something that equivalent to the reach of that same laser, that like that would exhibit the same quality because it's in a different it's a different wavelength. I don't know. It's like I don't know. Like you could play around with all that stuff. Nobody's saying like, oh, like a blue laser light drifts down more than a green laser or a red light. I don't know. I don't really even care. It's really just about waveguides here. That's why this is going on. It starts to angle down because of.
Okay, can I maybe respond because you're?
I don't think so. No,
putting more and more on top of it.
Sorry, I know what I'm talking about. I've had this discussion with many people over the years and stuff. Like, I'm secure in what maybe I'm not explaining my thoughts in the way that's good for you, but I'll stop now. Thanks.
Laser light is something different than normal light. So you on the one hand claim you know what you're talking about. On the other hand, you at the same time say I don't know what is the difference or so. That's why. And before we come to the how laser light refracts versus how normal light refracts, I think it makes sense to understand the difference between laser light and normal light, and if there is any difference between those.
Okay, well, I just know that.
Therefore, I wanted to ask you: do you know what is the difference between laser light and normal light?
Yeah, and I was saying something like energy density. You know, basically how many joules are in that light. But I only know this because like I know that I can't use my camera around lasers, or else like I could blow out the sensor. But that won't happen with sunlight or any other type of natural light. Cannot do that. LED light cannot do that. I just know that lasers can, blow your camera away. That's what I know. And if you want to say that that's just like a coincidence or something like that, then fine. But like,
no,
I would say that's due to some energy that's going on.
It's absolutely no problem for a normal camera to take a consumer grade laser, this 100 milliwatt laser, and point it straight to the lens of your camera. Nothing will happen to your camera.
No, a regular, like I go to a rock concert, you could like lose your camera off of that. Just a regular concert light.
No. The lasers in the rock concert are eye safe. So these, even if you get them directly in your eye, those which are directed to the audience. And it will blow
out a camera though.
No,
so what do you think about that?
Those which are directed to the audience are eye safe. You can easily straight look into them
you're
for the period of time they can hit your light. There may be other lasers pointed in the sky that have a higher energy density, but the sun always have a higher energy density as any laser that you can just buy, consumer lasers. I'm not talking about the stuff that that cuts
as a source. Like you mean because it shines on everything? Yeah, sure.
No,
but
you
like
can
to your eye, it will burn your lens out
lens.
or your camera sensor out, and
on a normal daylight. On a normal daylight, if the sun hits a white surface and you see that white surface is typically brighter than a normal laser.
This is clinical. You're clinical.
Shown from the same distance.
If somebody had a laser light test, right, and they did it like I explained earlier, from 3 different distances, all across water, and they all came up with the flat Earth result, like, so would something like that be interesting to you to know that this doesn't go along with the globe?
So we can definitely talk about laser tests. The thing is, you are talking about laser tests as if laser would be something different than, for example, looking the black swan. And the light that is reflected from the black swan coming to you or coming to your eyes underlies exactly the same physics as laser light. The only difference between laser light and other light is that laser light is coherent. So it has all the same frequency in the same rhythm. So you don't have multiple wave peaks at different points. All the wave peaks are at the same point in time. All the wave valleys are at the same point in time. That is laser light. It is in the same rhythm. That is the only difference. If it's focused or not, doesn't matter at all.
But it's straight, right?
It's the same straightness as every normal other light as well.
So flat.
Laser light travels as normal light straight through vacuum. And laser light and normal light refracts in the exact same index as every other light in the same frequency does. If you have a blue normal LED with a very narrow band,
you're talking to a robot.
For example, like
I guess.
If you have a normal blue LED with 500 nanometer or so, and you have a laser with 500 nanometers, the 2 lights would behave exactly the same through glass, through pressure gradient, and so on.
Nanometers.
Dude, I mean this in the nicest of ways, but dude, I don't give a shit about the lasers. I'm talking about this experiment or this observation that was made. All I was asking was, would that interest you to have a laser test? Like, if we're going to prove that the Earth is flat, let's go out and do this, right? You guys tell that to us all the time, right? You guys go out and do something, right? Somebody goes out and does something. So there have been people that have done that. I was just wondering if don't you find that interesting, or what would be your...
But Jared, like, those laser tests that I have seen are confirming the physics that we know already.
If we can't take picture over water, what makes you think you could send a laser signal over water? Yeah.
I do think you can't take picture over water. You can take picture over water. It will just be affected by refraction.
You can't. It's not. It's always so. It's so varying, man. you know, and there's so many different
take pictures,
and everybody got a different. Everybody has a different camera, different sensor, different conditions, different all kinds of stuff, right?
Those time lapses of the horizon, like the horizon over water. Like there's time lapse videos out there that show.
There's that, and then when you start like you figure like depth of field out. You know, you're going to have like all kinds of like crazy magnification and demagnification of the foreground and background. You know what I mean? Like depending on your zoom. Like it's just like fraught with a lot of problems and trying to like do anything scientifical, right? And now if you just take into like there's barometric pressure, man. Like barometric pressure is its own waveguide, bro. Like that's moving light at a certain pace due to whatever that humidity. Like all light is moving at whatever. It's like governed by that, you know.
That's what I tried to
local environment in situ, right? In situ, it will experience whatever kind of like impedance due to like atmosphere, right?
Different wavelengths of light have different effects through refraction.
Are you fucking saying something so broad, bro? Like address my goddamn point.
Yeah, I'm just doing. If you wouldn't interrupt me.
And first the fucking universe was created, yeah, and then what, Snooze? Yeah, thanks.
Dude, it's long diatribes is what
blue light have different effect by refraction.
I'm saying we're trying to do laps here, and this guy wants to set up traffic cones every fucking place.
The pressure gradient in atmosphere causes light to refract. And different waves,
I don't even
different waves are refracted differently. Or what was your claim? You said there's a wave function through the atmosphere. I can't really follow what you mean.
Did not answer his question. That's my bet.
Thanks.
All that for you not answering his question. Although I don't.
I wanted to tell you, if I can just take an aside here for 1 second, because you're not going to say anything that's germane to this anyway. You're going to talk about waves and differences in refraction, whatever. It's like not the point, but Jared, I was thinking that like your Viking name would be Yarad, and thank you. And your pirate name would be Yard. It's even more. Or anyway, Snooze, did you have something you wanted to just make a general? Why don't you make a positive claim? Because it's like it's in not answering this, it's like I don't even know what to do. I feel like
what's happening, Snack, is
trying to scratch this itch, dog.
The question.
Dude, here's my perspective of it. The observation is being made, right? And then they're taking it as if it's theirs now. And that if we don't believe that the reason we're seeing what we're seeing is because it's, refracting, then we're the idiots. So it's a genius move on their part. Come in, we have the observation. Obviously, the observation is always going to be there, but they just come in and hijack the cause. And it's like they do it. It's like a sneaky little trick. That's exactly what's happening here.
There is no trick in claiming you don't understand what the difference between lasers and normal light is.
I don't understand. Okay.
Then explain me what is the difference between those. Someone said energy density, which is just bullshit, has nothing to do with laser versus normal light. Do you have any other guesses what the difference between lasers and normal light is?
Nobody said that. That's what I'm saying. You're arguing against nobody.
Oh, definitely.
Yeah. That was never an argument to begin with, was it?
I don't think so.
Snax just said instead of looking at it like a bunch of light going in everywhere, somebody's looking at it like a laser beam. But nobody said they're thinking that a laser beam and scattering light is the same thing.
No,
like
exactly.
light scatter
laser light behaves differently. So if you show, for example, laser bending in a pressure gradient, that this is something different than normal light bending in a pressure gradient.
All right, hold up then, Snooze, for 1 second. The aquarium thing is always demonstrated with a laser pen, right? Laser pointer, right? So why don't they ever demonstrate it with like a halogen bulb? You know what I mean? Or an LED? What, like the only time we ever see that dramatic thing going on with it is that I can use that same pointer and point it into my P stream, and it will hug that same because of internal reflections. It will stay within there, and I can light my P stream up, even if it's bent. Okay, it'll stay in that waveguide, and that's what I was trying to explain to Embo, but he ran away too. Just as I expect that you will run away too once you start to understand that I understand what the fuck optics is. Jesus, like, you're trying to tell me that that there is no difference inherently in the type of energy density of a laser versus normal light. I don't know, like there's a lot of lights, man.
I definitely claim that there is no energy density difference between laser light and normal light. And the only thing is why they demonstrate it with a laser is because it's just easier to see with a laser. I know back in the time when I went to school and we talked about refraction and we had lenses on the table, we didn't use lasers. We did use just a normal lamp, and we had a sheet in front of it with some slits. And through these slits, a light, kind of a light line was emitted, and then these lines were shown, were hitting a lens, and so on. You could see the reflection. You could do the same experiment.
That's how you do it on the lens bench. Yeah,
you
like
can just you can just
build
do
like
the
an
same
optical lens
experiment
bench,
with an aquarium. Can you just not interrupt? I also let you talk. So you can do the same thing with an aquarium and with a normal light bulb and with these sheet with a slits in there. No need for a laser. You will see exactly the same.
Don't take my name in vain.
So then doing the observation with the laser would be wrong? So if we were to do a flat Earth test,
the observation with a laser is exactly the same equivalent as an observation with normal light.
All right, so it like let's say you had so here's something that's built like in an optics lab. It's called a lens bench, right? It's basically a rack where you can like adjust and set up different optical elements, right? Like a double convex, a concave. You could set up whatever situation you want to, and you're just trying to see what that path of light does. You're going to use a laser pointer to actually see where these reflection points are and how that geometry actually works. That's what you would not use a laser
something
pointer
else. Because the laser pointer is only going through the air, and you won't see the path of light on the bench. That's why you don't use a laser pointer in that case. You use a light that is actually
this fucking guy,
out.
dude. Honestly,
So
like
you see the
whatever
on the bench,
whatever reality you come from, it's like we don't come from the same reality. I don't think so. It's fine.
So you use a laser because it's straight, and it's straight. Anytime I've ever used a laser, it's straight ahead, doesn't bend. But once it gets out of our reach to prove anything, that's when it starts bending.
You imagine an automatic laser level bending to create a level plane. Weird.
You're trying to see the side profile of this laser, right? So you're trying to see the side profile of where it's going up and down and reflecting into each element, right? So you're not trying to shine it through the lens train. That would be maybe you would use a light bulb, or you would use a projector or something, like just regular light to put a test pattern up, and then you would see like what that actually looks like. But to just see the optical pathing, you're using a laser because it shows that, because you can see it that way. And whatever dimension Snooze comes from, that he has his own reality. I guess I have my own reality.
I just posted a video in the chat. Go to minute 3.
Minute 3.
Or actually, let's start at minute. Moment 220 or 230 or so.
Where did you post? Here, okay.
Sorry, so would you use a laser to measure flatness on a flat Earth?
236. Go to minute 236. You will see there is a normal light bulb, and then you put a sheet in front of the light bulb with a gap in that light bulb. That is typically used to follow the path of light, to demonstrate.
I'm gonna wait for this commercial.
And this behaves exactly the same as a laser would do.
Would you use a laser to measure flat Earth?
Oh, 2 commercials. Red Bull gives you.
I mean, would
guys.
that be your premise? I mean, it's. You can steel man it, right?
What premise?
Measuring flat Earth. Like, how would you do it? With what laser?
What the fuck
would you
are you?
use a laser?
This is stupid. Whatever you're pointing me to here, guy. This is dumb.
Typical benches where you demonstrate like refraction or so, it's just done with normal light. It's not always done with lasers. You can do it with lasers, but then you have to take care, for example, that you have a visibility in the air, in the path of light, for example,
lens,
by
guy.
fog.
You're showing like one lens. That's why you can do it like with one lens, because it's got very, very low resolution for doing it like this.
Also with multiple lenses it works.
Yeah, he's not setting up multiple. There's not multiple elements, guy.
What the difference is, but I think
show me multiple. Yeah, because you can't set up multiple elements. That's why it's single. This is just a dumbass demonstration.
You can just use a sheet with.
You're trying to use some like Sir Isaac Newton level shit right here. You know what I mean? I'm saying this is not no like modern way to be doing. This is a way to teach like a 101 level shit, which obviously I'm speaking about like lens design itself, like building optics. You know what I mean? Like yeah, you can demonstrate one element here, but try and like put a whole train together. Like on this demonstration, you can't. And you can only do it like this on half elements because you're crashing the optical or there's a beam that's being projected, right? It's not a point. It's not a collimated thing. It's on the surface of the paper. Okay, so you can only do this demonstration like this. I mean, it's a limited thing. You're not building a camera like this anyway. So whatever.
Well, I don't even know
by calculations because we know how light behaves.
Yeah, you can calculate the angle of refraction. You could calculate.
You don't have to test that stuff with lasers and then look to it. You're actually building a camera by developing the corrections for different frequencies. You're doing coating on the glasses to reduce the different refraction indexes based on different wavelengths.
Using this method, it would take you close to a year to design a 3-element lens.
No, the thing is, lenses are not done by trial and error in a lab by moving that stuff. Lenses are calculated.
Used to be. Lenses, when they're made by people, are lenses that have been made since 1986 have been designed by computers exclusively. People cannot do the fucking calculations, man. Any lens that's made by hand is done for art's sake or something like that. It's not because it's all pre-calculated. It is on tables. Fucking optical science has not fucking really changed much since fucking World War II.
Ever heard of a laser disc? Yeah, what? No, but honestly though, like, would you use a laser? Like, if somebody told you, "Hey, I want you to go out and measure, like, how flat the Earth is," like, what would your approach be? Would you get a laser and find a body of water, or like, is there an experiment that you would set up that would help you prove that?
So a laser has also a lot of convergence. So lasers spread out over distance. As further you get away from the laser, as bigger the dot will be. And after like something like 100 meters or so, you already have something like a 50 centimeters dot or something like this. So it's get bigger and bigger. So looking, for example, to where the laser dot is shining doesn't make any difference. And if you look through a telescope to a laser, then the only advantage of a laser is that it has kind of a good, how do you say, like energy to direction ratio. So instead of a normal LED or a normal light that is unidirectional, that is omnidirectional in all directions, a laser is more or less unidirectional. So all the used energy is sent out in roughly the same direction. So you don't need a high power lamp to see the same amount of light. That's the only advantage of a laser when you try to measure like flatness or whatever.
So then, yes, you would use a laser.
I did not say that. Did I?
Well, that was a long answer to an easy question. Would you use a
Problem with
laser, or what
optics.
would you use?
So first of all, if I would want to try or to measure the surface, I wouldn't do it on ground level. I would do it from mountaintop to mountaintop, or from one mountain range through a valley to the other mountain range, or something like this. And the other thing is, you could also use geometry of the sky and so on. Just looking over water, where we know that the refraction is in a very wide range. So the predictability is not very good. Doesn't make any sense.
So Snooze agrees with Snax's future. Get that shit. Put that on the fucking headlines. Print.
Why do we agree?
No, all right. But I did say that before Snooze.
Where do you think we agree?
That like using optics over water is a real like dodgy way to try to do any kind of exact measurements of any, especially about this.
We agree. Yeah. Optics over water is not a reliable measurement if you don't know exactly what you're dealing with.
Why don't y'all go back to the whole argument to begin with that bottom-up obstruction? That was what his original argument was about, that the bending of light would cause bottom-up obstruction.
Was that him that we were talking about that? I think so.
I don't know.
Yeah.
It's been so long now. I've done forgot. That's what the whole argument started about, but it just sort of got lost in the weeds.
I guess I fucked everything up. I'm sorry.
No,
I apologize.
No, it wasn't
you're
you.
Good.
But yeah, I thought we were on the Roohif aquarium, Age of Aquariums.
Well, I mean, are we going to report like abuse of fish? Because you can't put sugar in a fish tank like that.
I mean, I thought that was humorous earlier.
It was fun. I liked it.
And then Roof had to feed the dogs or whatever. But
that's obviously what he has. It's a bunch of dingoes. Just
with the refraction gradient, like you're talking about water to like unknown amounts of sugar that you're just going to add and just dump into it, right? Like,
yeah.
I don't know what's scientific about that. Like, I guess probably Jesse would have like figured out like what it took to do the refraction thing, and then maybe could have like figured out how many moles of whatever he has on his face, and then he could have figured out what that density ratio is really, and then do an equivalent like measurement, like to make an equivalence, like if you're just doing like a demonstration of optics, it's like it's fun, but like to say that it proves something is an annoyance, and it feels like gaslighting a little bit with that. But what was the whole jazz about like the flashlight to refraction to laser light to whatever, to like spill? Like there's just always spill of light, like difficult to stop it.
My thing was with Roohip was the whole bottom up extraction. I disagree. I don't think that can only happen on a ball. Like, I don't believe that at all. I think it could totally happen on a flat plane with things that are moving away from you and then disappearing into the horizon. I've seen mountain ranges appear in the horizon, just pop, they're there, So, I mean, things are going away from you.
Yeah, because you're from Flatland, Kansas and such.
Yeah.
There's not too many mountains in Kansas.
No.
Are there none?
I think there's like I don't know, it's like a hill, and they actually
people go skiing there.
Probably made out of garbage.
But then you went like,
dude, have you ever seen the fake snow? Like, that's weird. They put fake snow up there and people ski, I guess.
I've seen it.
Super weird. But yeah, no, Kansas.
But then you got up to like New Mexico, you got up to like some mountains, and you're like, wow.
No, what was cool was driving down I-70, right? Because I'm thinking in my head now, okay, I'm going to make sure I know when I see that Rocky Mountains and how I see them, and I'm having all this anticipation. And then just out of nowhere, boom, they were just there. They just appeared. It's like a magic trick. You know what I mean? Like and that's the best way I can describe it. Like there was no like gradual nothing. It just boom, there they were.
Onita, I call your name. Was like first there is a mountain, and then there is no mountain, then there is the name of the song.
Oh.
And it's a good one to put on the car because it's a long drive, probably if you're driving the mountains.
Well, from I-70 to Lyman, and Lyman's about 59 miles. So you had to be southwest from Lyman. So right around there is when I see the Rocky Mountains, which is trouble. I mean, that puts a globe. I mean, I don't think I should be able to see that on a globe. I haven't done the math on it, but yeah, my observation doesn't match. I don't think what the globe would tell me what I'm seeing. And even if I did make the observation, there would be somebody that would, hijack the observation and make it theirs.
I feel like even, it's like haze and humidity. It not only like has its own like local weird pocket, but it's like it's sometimes magnified. Like if you're in a distance from a mountain, so you're like in one humidity pocket, looking through another one up to the mountain. And I think sometimes you get some crooked shit looking that's going on, man. But nothing explains that fucking moon, dude. That thing is weird. Like it's like the sun. I'm always it's easy, But the moon, it's like following you. Like you're like, I thought I lost you. I took 2 lefts in a. You know what I mean? Like I think
there's so many times when it'll sneak up on. Like I'll see the moon and it's full, and it's bright as shit, and it'll be like on the horizon or like right above me. Like, but it just looks bigger sometimes.
Like it's driving around, but like I don't know. I guess if it were overhead, I wouldn't be seeing it whatsoever, right?
I'm gonna post a picture in the chat. Look at this sky that I took from my workplace. This is no camera filters, and I swear to God, the sky looked like it was on fire the other day. I've never in my life seen the sky look like this. You guys got to check this out. Let me get it. Go ahead and continue.
I seen like it was mostly overcast all day today, and then just like I could see like a little rip in the clouds, and it was like this bright red fire kind of going on. It was like sunset, but yeah, we got a little snow now, so I'm sure Jeremy's going to be shoveling his driveway today.
Yeah, dude, and driving to Kansas from Colorado, last year, right around Thanksgiving, the moon was, me and my son were driving. My son was like, geez, Dad, look at that. And it was creepy looking. It was huge. And I don't know if my mind was just telling me that or whatever, and if it was actually like bigger.
Yeah.
But it seemed to me like, dude, that it looks like it's close. Like that ain't no 249,000 miles away or whatever they claim. It's just funny to me.
Cole, what I think is going on here is like you're in a sandwich. You're like looking at a cloud sandwich. So there's like upper clouds up above this, and they're creating this really like diffuse light. And then the bottoms of those clouds are more in eye shot of like whatever that horizon line is. So it's like you're either catching like a sunrise or a sunset here, right? Or a sunrise maybe?
Yeah, it's sunset.
Sunset. So as like that horizon, whatever that horizon line, it's like casting that red that the clouds are picking up, right? But there's still a lot more diffuse light above it, like that's creating that difference, right? So
yeah, it don't really come through as much on the camera either, but it looked like the sky was on fire. Like I've never seen it so intense. It was really cool.
Is it cold where you are?
Well, so yeah, it's in Tennessee, and it was maybe
that video. I think it shows the very very red, like orange.
Dude, in the camera, whenever you take pictures like that too, like I know what you're saying, like it looks smaller than what you know what I mean? Like I've done that before too, where I've taken a picture of the moon thinking, oh man, I'm gonna take a picture of this. The picture comes out like tiny.
Yeah. I think that there is something, even though we can quibble about nanometer wavelengths and harmonious things, that there is a qualitative difference between what sunlight is capable of rendering to our eye and to that of photos, and different, like a cell phone camera. It's like that's a teeny weeny sensor, or even if it's kind of large, it's not like, I guess they make them better now, but it's like a lot of it's digital signal filtering and things like that. But I don't know. I just know, like, from like trying to grow like a little plant just on water and lava rocks, that like basically only sunlight could sustain it, really. Like no other artificial light sources would do it. I think that there's something like unique about how sunlight works. It's awesome.
That's kind of cool too, because when I leave here for work, I get to see the sun come up, and then when I leave from work, I get to see it go down.
You know what's interesting? A little science project would cost you nothing. But if you got somewhere where you are at and you're at high elevation, I think you get a higher UV and IR index because there's less clouds cover. So like where Cole is, he should be more shaded out, generally because he's at that cloud layer, so there's like a filtration layer.
Yeah, it's
up in
weird,
the mountains,
dude.
I don't think you get that as much, and so
you get burned differently for sure. Like when you get sunburned to here, yeah, it's a little bit different.
It's generally like higher all the time, but you can take like different rocks that you find. Take some different rocks and lay them out on like a table. If there's somewhere like you hang out like in the morning, having a cup of coffee or something like that before you go drive or whatever, you can check out like a lot of these rocks will like heat up pretty quickly, or they won't heat up quickly at all. Like there's a whole difference in like how much light gets absorbed from these different, I guess because of ejection of whatever the light frequencies, or depending on like what kind of materials the thing's ultimately made out of. But I find it really interesting. There's all these certain types of rocks will heat up faster, and they become parts of the whole topography of everything, like over time. They'll melt the snow off faster, and then that'll cause runoff, and then a fucking chipmunk goes and gets, I don't know, leverage, just shit over time. You start looking how the mountain biome, it's fucking awesome, man. I wish I was up there. I love it up there. Crazy ass sky, huge ass sky, dude. Oh man, wow. No trees.
The anti-crepuscular rays or whatever. Dude, there was this one time it was tripping me out. It looked like there was this, two suns, dude, and it was that anti-crepuscular effect. And I was like, oh, that's what this is, because it was tripping me out.
I one time caught like the most amazing crepuscular situation. It was a little bit like what Cole's picture was, but the sky was a little more blue, and so it's really popping. And then all those rays were hitting on like an underside of a cloud. So it was just like a bunch of crowning like red rays, like or pink and blue, basically, kind of splaying out. It looked a lot like if there was like a pink and blue version of like the Japanese flag. That's what the sky looked like, and I was like, that. I wish I could have. By the time I went to get the camera, it was gone. Amazing. That's why I always have a camera on me now, in case that happens. I went up taking like crazy pictures, like while I'm out, like ice clouds and stuff like that, sundogs, stuff. But it's always like from this one area. I notice it. It's like a big flat area that out here where it's just like it gets really windy for some reason, and cold, and that's where I always like spot these like kind of ice clouds. It's strange that like I always spot the ice clouds there, but then not other places. I find it, or maybe I'm just like out there at that time of the day with the refraction hits, and it makes that happen. But I don't know.
I wish we had like that Pee Wee Herman. You said the word of the day or whatever. You said refraction. Everybody goes, ah!
That when everybody says scream real loud. What can you be Conky 2000, or maybe Cole could be? You'd be what kind of? You do a Conky 2000?
I don't think so.
Cole would be the Tex guy, the cowboy dude.
Cowboy Curtis.
Yeah.
All right. Yeah, you're more the Randy of the. No,
it's funny. Like I always think of
the Randy.
I always see these words that people use in these rooms all the time, and I just think it would be funny if we did pick out a word, and when somebody said it, just everybody just goes, ah! I don't know. It made me giggle thinking about it one day.
And I was just raised by the television. I'll always comment on television.
You and me both, brother.
One of my parents.
Yeah, dude, that show was funny. I'm sorry. I don't care. I liked it.
Man, they had it out on him, dude.
His documentary, I think it's on Netflix. It's not bad.
You see it? Yeah.
Paul Rubens, rest in peace. I guess.
Oh, there's another one. Oh, yeah. I watched like the doc where it's like him talking. Basically, he did like 500 hours, and they cut it down to whatever.
Yeah, that's the same one. Yeah, it's because it's.
I hope they create a museum from his. He had like this incredible collection of toys and memorabilia and all kinds of junk. Like. Like he apparently like has enough probably for a museum to, to put up his own.
And spoiler alert out there, kiddos. He's gay. I don't know if anybody knew that.
He's like massively. He's like not massively, but yeah. Like
he faked it like with a woman. Remember, like he started with a woman because he was faking it the whole time, and then he got away from his daughter.
It's like. Yeah, but I don't know if like I don't know. It was like always Miss Yvonne had like the huge, the enormous cans.
Dude, that's George Costanza's mom. That's her.
What?
Isn't that crazy? Yeah, that's George Costanza's mom.
The actual?
No, not George.
Wait.
No, I take that back. Sorry, I'm thinking. Sorry, mixing up.
The fictional George Costanza or the real actor, Jason Alexander?
Forget I said that. Not Seinfeld. It's Always Sunny in Philadelphia is what I meant. He's Charlie's mom. And It's Always Sunny. Sorry, I mix those two up sometimes.
I'm all confused now.
Have you ever seen It's Always Sunny in Philadelphia?
Once.
Okay, so you don't know the show, so yeah, sorry. Anyway, she plays Charlie is,
oh, Charlie Day, yeah, talking about. Yeah.
Yeah. Well, Charlie is his name in the show too, but that's his mom is who that woman was from Pee Wee's Playhouse. Like when I saw that, it tripped me out.
All right. I
was like, oh my god, that's whatever. But yeah, dude, that was
the movie is pretty much like I think what I was like where I got it, like I guess like Pee-wee's Big Adventure is a dope movie. It's like it's Tim Burton's first movie.
Tim Burton, yeah. A lot of people don't know that.
The soundtrack is dope. Yeah.
Yeah,
I don't own it. I don't know.
Dude, it's a creepy movie. I remember watching it as a kid. It creeped me out when he gets in the truck with the lady.
Well, that's when. And then the clowns. There's like clowns that are taking apart. They're stripping the bike. You know what I mean? Taking it apart. It's got
and the big dinosaurs or whatever.
Those dinosaurs are no longer there.
I did, and that. Yeah, weird movie. But see, I as a kid, I thought that was who he was. Like, I didn't know that was all an act. You know what I mean? Like, that was him just totally being that way.
Yeah, it was the 80s.
Yeah, I thought that's who he was. I thought that's how Paul Rubin is. You know, I just accepted it, I guess. And when you watch the documentary and you see him talking normally, and you're like, oh man, I had this guy all wrong for the longest time. He actually did high facial face or whatever.
Yeah, we can't be talking about Pee Wee Herman for too damn long, though.
Oh, sorry.
I think we've hit the Pee Wee Herman limit.
Okay.
The zero barrier. I don't know.
Back
we have to deploy Bruce Willis to explode this conversation now.
Get us out of here. Okay.
To drill a hole right through the Pee Wee Herman conversation and plant some explosives and save the world, basically. Say some Aerosmith songs. Do you miss movies like that? Cole, how do you feel about like that? Or you probably, I'm probably stepping on your.
No, I don't. I mean, I like movies like Bruce Willis movies like Die Hard and shit.
Armageddon. I'm saying,
I wasn't big. I didn't care much for
Willis
Armageddon.
in space. You know what I'm saying?
Here's a question I'm asking everybody.
I didn't care much for Armageddon.
It's like Die Hard in space, a little bit.
Yeah, but
so is Die Hard a Christmas movie?
The asteroid should have had a German accent.
No, do you think Die Hard's a Christmas movie?
Die Hard is the greatest Christmas movie that's ever been made or conceived of or will ever be made.
Everybody I've asked, everybody at work, everybody says the same. Die Hard. It's so funny.
Part 2. I like Die Hard with a Vengeance the best.
It is a good one. Those are good. But yeah, Die Hard 2 can definitely
original Die Hard.
For whatever reason, I don't know why. I don't think of Die Hard 2 as much of a Christmas movie when it had just as much of a Christmas theme, right? Like, what shitty luck, by the way. That was one thing that I always said. I was like, man, this guy gets a bad Christmases.
I kind of wondered, like, it might be like due to popular hallucination, it might have came out around the same time that like Home Alone came out, or you know what I mean? Like they might have tried to pair those because they were all Christmas movies.
Seeing this ad? Check the